Welcome back. Today we are looking at chemistry. We are looking at atomic structure and periodic table. Question 1 says an aluminum atom has a nucleon number of 27 and a proton number of 13. How many neutrons does this aluminum atom contain, right? This is like a mass number. So they just give us a mass number of aluminum which is 27, and they give us protons. So we're going to say 27 minus 13. Remember this mass number, and then this proton number. So we want to find what neutron. 7 minus 3 is 4, 2 minus 1 is 1. That will be 14. Question 2 says an atom of element Q contains 19 electron, 19 proton and 20 neutron. What is Q, right? So we are going to look at the chemical property of this. So it's going to guide us. Remember the electronic configuration. The first shell can contain 2, second 8, third 8 and 18, right? So by just looking at 19, when we remove 2 from 19, this will take 2, we remain with what? 17. And then when we take 8 from 17, we remain with 9, right? So we take another 8 from the remaining 9, we remain with 1, right? So it means that that 1 shows that that element is in group 1, right? So we know that this element is in group 1, right? So this will be 1, 2, 3, 4, right? This element should be in period 4. Let me quickly look at the periodic table, right? Yeah, on the periodic table we can see that here is the group 1, right? And we saw that that element, it is in period 4, so that will be potassium. So we're going to look for potassium. So we can see that here is the potassium. That's how we find it, right? Let's go for question 3. So question 3 says the table shows the atomic structure of 4 atoms. Which atom is not a metal, right? So we're going to look at a chemical property again here, right? When we look at A, remember the electron configuration. We know that 2 plus 8 plus 8, let me write it. The first shell, second shell, third shell, right? We know that 2 plus 8 is 10, plus 8 is 18, 36, right? So we have 18 here, so which means that the last shell or valence shell, it is full occupied, right? It has 8, right? So this is probably likely to be a noble gas, right? So this valence cell is full occupied, right? So this one is likely to be noble gas. So you are lucky. So the question says not a metal, so this is a noble gas. So the last one you can see that is 19, so it has 1 electron and then 1 electron, 2 electrons. So these are property of metal, right? And then let's look at question 4. Which statement about atom is correct? atom contain proton and electrons in the nucleus, right? So electrons are out of nucleus, right? Neutrons are negative charges from neutral. So negative does not match with neutral, right? Proton are positively charged. This one is correct. The nucleon number is the number of neutron. So this one has left proton out. So that's why it is not correct. So the best answer is C. Going for question 5. Yeah, with question 5, it says which diagram correctly shows the ion present in compound of potassium fluoride, right? We know that potassium is metal, right? This is a non-metal, right? So metal donate electrons to non-metal. So let's quickly do some structure for potassium, right? So let me show you the periodic table again. We have the potassium here, right? Remember the proton are equals to number of electrons, right? So our proton number here is 19, right? So we have potassium, which is K, is 19, right? Our electric configuration, we know that the first shell, second shell, third shell, and so we are going to break this down. So 2 remain with 17, we take 8, we remain with 9, we take another 8, we remain with 1, right? So 2 plus 8, 10, plus 8, 18, plus 1, 19. So when you add this together, they give you this number, right? So we know that this has to, and the potassium must have what? 4 shell, right? 1, 2, 3, 4, right? So it must have 4 shell, right? And the last shell has 1 electron. This electron is the one that is going to be given to fluoride, right? So let me draw the last shell, right? Like this. It will have 1 electrons, right? This is potassium, right? So this electrons is going to be given to what? To fluoride. So fluoride, let me use dot, right? So in order to obtain its octet state, right, it will be given 1 electron, right? These are dots, and this electrons is given to fluoride, right? So this a fluorine, so the electron is given to it, right? So that last valency shell, it will remain empty, right? So we're going to remove it, and we're going to remain with this 1, 2, 3, right? So we're going to look at the one with the 3 shell for potassium, right? So here is the potassium. We can see that we have 1, 2, 3, 1, 2, 3. Automatically we eliminated this, right? So now we are going to look at add the charge here, right? So we have plus, right? We have minus, right? So C is going to be the best, right? We just eliminated by this strategy. So you can also use the flooring if you want, and this method continues to apply. Question 6. What does the nuclei of hydrogen atoms contain, right? So we can see that in this we have one proton, this mass number, right? So hydrogen has one proton and one electron orbiting around the nuclei, right? So 6 aces, electrons and neutron. Remember, nuclei is the plural of nucleus, right? So that's why they say electrons and neutrons. And then electrons and protons, right? So these neutrons make this not to be correct. Neutrons only, this is not correct. Proton only, so we have electrons and protons. So we are likely to take D here, right? Because electrons are just orbiting around the nucleus. So D is the best answer. Looking for question 7, says the table shows number and the nuclear number and the number of neutrons in one atom of isotope W, X, Y, Z. Which statement about W, X, Y, and Z is correct, right? Remember, isotopes, they have the same number of proton, right? Proton are the same, right? But neutron are different. So this is the statement that we are holding now. And then we are going to W and X are isotope of the same element, W and X, right? So let's look at the neutrons. The neutrons are different, right? The statement. And then nuclear number, we can see that it is the same, right? So this is likely to be correct. X and Y are isotope of element in the same group of the product table. X and Y the neutrons are the same, but this will be wrong, right? So neutrons have to be different. C says X and Y and Z are isotope of element in the same period of the periodic table. Y and Z, yeah, that talk about something else here. Z has a high proton, so our answer, the best answer is A here, right? So going for question 8. Question 8 is like question 6, right? So we choose proton only, right? And then 9 says the relative atomic mass of chlorine is 35.5 When calculating relative atomic mass, which particle is the mass of a chlorine atom compared to? Right. Remember, everything in the periodic table, every element is compared to mass of carbon 12, right? Carbon 12 isotope, right? So that's question 9. See, that is the best answer. So we're going for question 10. Atom contains electrons, neutrons, and protons. What is the definition of nuclear number? Right. Number of neutrons in the nucleus of an atom. I'll talk about neutron and protons, right? The number of protons in the nucleus. No, we're excluding proton. I mean neutron here. The total number of neutrons and protons in the nucleus of an atom, right? So the total number of particles in an atom, right? So no, 10. C is the best, right? So we'll go for question 11. So number 11 says the diagram shows the atomic structure of an element X. What is X? So let's look at the electrons here. We can see that there are 3 electrons. So this last valence shell shows us that this thing is in group 2, right? These two electrons shows that we have group 2. Period, we're going for period what? We count number of shell. This first shell, second shell, right? And this must be in group 2, period 2. We're going for periodic table again. So we have group 2 here, and then period 2, this one. So beryllium is the one, so let's check for the beryllium. So 11, the best is the beryllium. So and thank you for joining us. That's where we stop. If you want more, remember you can contact us on the number provided. Thank you for joining us. See you next time. Bye bye.